Hi, for this session, before going to the demo session, we need to have certain prerequisite met. So let's see what are those. So you should know about building Linux kernel. That's pretty much important if you are going to build a UML image from your source code, Linux source code. And you need to know how to configure kernel because we have to enable few options here and there if required. And third, you need to know about GDB. Basic knowledge is fine. You should know how to set a breakpoint, loading a file with the debug information, attaching to the process. This three things should be fine. Apart from this, if you know about dumping certain things like dumping the registers, printing the variable values, printing the variables, dumping the memory address, that's well and good. Like that'll be much easier to go through the entire process. Let's look at list of tools which are used for debugging, and I'm primarily going to demonstrate how to use user mode Linux to learn various flow in the kernel. So let's start with the tools. Okay, so we have KDB, first one. We have GDB, and we have KGDB. In case if you are done it before, it's good. And we have UML, and we have LKCD, Linux kernel crash dump. So we are going to look how to use UML and how to use GDB in our demo session. So how you can use these things, like what I can do with UML and GDB. So UML, it's a special, it's an open source project uh, where you can learn Linux inside Linux. So the new Linux will be a normal process, like the way you execute ls. We have cat, any normal shell command. So first thing is you can either compile a UML if you have a kernel source code, or you can download a pre-built UML kernel if you use Ubuntu, Arch Linux, Fedora, anything. So demo session we are going to use mainly Ubuntu 12.10 version. It's a 64-bit version where I'm going to show you the kernel compilation and how to do a couple of things. Okay, let's go to the screen. So first thing is just untie your source code if you have, or you install the source code package, whichever is applicable. Make sure you start with a clean kernel source tree. Just do a mr proper. So that since I have a since I already compiled some kernel, so it's going to take some time. Let's wait for that. Okay, so it's pretty good. Now let's uh, let's add the default kernel configuration file for UML. It's just you can use this step. If you want to know more about UML kernel compilation, you can go to UML website. You can find it in Google. Okay, so we have done the def config. So second thing, once we have done the cleanup, def config, sorry, the third thing, we have to make sure some options are set up in the UML kernel config file, especially if you are using Ubuntu 12.10, and if you are using it for UML compilation, make sure you make sure to follow the step what I'm going to show you next. So make arc menu config arc equal to um. Okay, so since it's the first time this compilation is being done. If you are doing it, if you have done it before, then you can directly go to the menu. Okay, so you can see it's the make menu config shows the configuration for UML. So just go to general setup and enable initial RAM file and RAM disk option. So you can see the help. It says config underscore block underscore dev underscore init rd. So that's a pretty good thing. Uh, because this function, this particular option has some dependency with the kernel compilation and a lot of other things. If you disable it, the UML compilation will fail, and you might be thinking what's gone wrong. And instead of wasting time and debugging in it, just you can set it. Probably the future Ubuntu will have this issue corrected. Okay. So second thing, just check for kernel hacking. So kernel hacking, you can see first thing is just check whether kernel debugging is enabled. Yes, it's enabled. That's pretty good. You can see it is set to config debug kernel. Second thing, you can just check. You just check whether compile the kernel with debug info that is set. Good. So that is config debug info. So both the options are set. If you want more debugging information, like say you want to deal about locks or you want to debug about the scheduler, you can set these options. So it's pretty much play around with it. You will know, you will learn a lot. So for just to start with, we are just going to set these two options, exit out of everything, just say yes. Good. So now let's clean the screen and we are going to start the kernel building, sorry. Okay, so I'm just going to start t1 and t build out. So I'm just using this to make sure the kernel debugging messages are shown on the screen, as well as the same time it is returned to a file, so that if the screen scrolls up, I mean it keeps scrolling. So I just want to take a look at the build. If something goes wrong, I can open this file and see. So it's pretty useful thing. Alright, so let's start it. You can see it's running kconf. Okay, this header. Alright, so that's good. So kernel compilation has started. Let's hope it goes all the way through. We started the kernel build, and so I just did the build. So now we have VM Linux and both the Linux, so it's pretty good. I can do a just file just to make sure Linux VM Linux. So it's a ELF Intel 64-bit file. Okay, so well and good. So next step is we need to launch the Linux. So let's go to the root. Okay, so since I already typed the password, it is there. So all we have to do is like start the Linux. So this is a command line. This is how we execute the UML. You can check out the UML website for more information on how to run it and how to give extra parameters. Okay, so it's just Linux UBD0, and I have downloaded a pre-built Debian 64-bit file system. So it doesn't matter. So for even you can run this file system with our UML Linux. Okay, so all set. Let's start it. You can see the usual boot up messages, this, that, blah blah blah. All right. Okay, so you can just ignore the error messages, since we are not going to deal with the modules debugging or anything. Okay, so let's log in. Okay, so we got it. Let's say ls minus l slash. This is our UML Linux and the file system running everything in memory. Okay, so now what we do is just go to the other free terminal and note down the process ID of the UML Linux process. Okay, so let's note on this one first, 3452. Okay, let's just copy it. Let's keep it handy. Okay, so now what we have to do is, like, now let's say I want to uh, start debugging the I want to debug the sysclone system call. Okay, so let's go to the kernel directory, user src linux source. uh, this is in my Ubuntu system. So if you have a directory somewhere else in your Linux, you can go there and start the GDB. Let's say, okay, so now let me just say GDB followed by Linux. So let's wait for the GDB to load up. Okay, now let's do list and let's see the sysclone source code. Okay, so it's pretty much it. So what we are going to do is we are going to keep the breakpoint on line number 90 where it calls the do fork. Let's keep it be 90. Okay, so it says syscall. Since we have done the listing, if you say b90, 90 is the line number, GDB automatically assumes the function uh, where wherever the function, whichever file the function is present, like that's where the line number is. So it's well and good. So life is very simple. Okay, so now we have done a breakpoint. Just to make sure, we just say info break. It will show you the breakpoint. So second thing is we have to attach the process. We have to attach to the running kernel. Okay, so let's do that by saying attach. Um, okay, just a second. Sh. Okay, so let's start from here. The first line. Print info break again, just to have a few enters so that we come to the middle of the screen. Then say attach followed by the PID. Since we already saw the PID 3452, so we just attach to the process. Okay, so looks like there's some problem with the thing. Just a second. Oh, we have to go to the root. Sorry for that. This. All right. Now do a GDB Linux. You have to repeat the same step. Okay, so let's say same thing. List sys underscore clone. My bad. Okay, so we have to keep the breakpoint in line number 90. Okay, info break couple of times. Then we do a attach followed by the PID. Okay, so looks like everything is done. Then all we have to do is do a continue. Yeah, that should be fine. Or just you can just say C. That's fine. Okay, let's go to the other terminal. Now we do a ls minus l slash. Okay, so it looks like it has hung, but in the reality it should be waiting in the GDB. Okay, so here it is. Let's just say step here. Okay, so if you look at here, we are in the do fork function. You can see the things here. We are in do fork. Let's just say next for couple of prompts. Next. You can just say enter once we type the command. Okay, so now we have done the copy of the task struct. That's a process representation on Linux kernel. Let's say p star p. Oh, okay, so this is the task struct. I'm sure like you cannot do anything with this. Let's just print out p pointing to okay, now it's set to 0. This is a memory structure which is used for the code data base stack, the entire thing. Let's just keep it okay. And so what we do is we just go through the entire thing till the return from the do fork. So then we'll just try to print one of the task struct members to see whether what is set. Okay, so looks like we are in the sysclone. Let's do a BT. So we are still in sysclone and list. Okay, we are out of the sysclone. So what we should be doing is like cone flag, and let's print the parent TID. Okay, it's a local variable, that's a problem. Alright, clone flags. I think, yeah, we are pretty much out. We should have done the breakpoint before. Not a problem. So we just say continue. Okay, still you can see, like, let's do it one more time, and let's print something else. Say step, next, 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 and then copy error trace nr set id. Okay, task pid clone. So let's do the let's print the now. Hopefully, because it's doing a wake up new task, we should be filled actually. P pointing to mm. Yeah, okay, you can see that, like, you can see, like, the entire thing. Obviously there's one more thing, P pointing to active underscore so that is also same. So let's do P star, say P type P type P P pointing to Okay, so this is the struct. um, so it contains the entire process related thing. So you can just say we'll print one of this, say map count, or mmap base, some variable, like, which makes, like, proper sense. um, let's say exe file, no, arg start again, the start brk. Let's do this. Let's say the start code. So let's say print p pointing to pointing to start underscore code. Okay, so let's print that in x. Okay, yeah, so that could be the address of the starting of the code. You can see the other things like data, everything, brk, stack. You can also print the stack. Let's see what is there. Okay, so that looks like some 64-bit thing. Alright, let's just delete the breakpoint, since we have seen what we can do with this. Delete the breakpoint, yes. Okay, so now since we can say continue, and the ls should be coming out, yes, we can do it again. Okay, it didn't hang this time since we had deleted the breakpoint. So now all we have to do is press Ctrl C and do a detach. Since, like, we are still attached to the program, we have to do the detach, and you can come out of the GDB safely, and still the kernel will be running without any issues. Okay, so this is a very simple step uh, to just run the UML kernel with a pre-built file system, and uh, bring up a GDB attached to it, set a breakpoint somewhere, the function you're interested in, and you can see the flow, and then you can finally do a delete breakpoint and detach. You can do it. So this will help you to go through the entire kernel code, uh, at least the few non I mean the few device independent code, which is very, very crucial, like scheduler, memory management, and file system process management. Okay, so once you're done with the debugging, let's say we are done with all that, just do init 0, like the way normally you do it in the Linux system. You can use shutdown command, init 0, whichever works out well. Now you can see it has come out, the process has been killed. We are still we have come out we have come to the command prompt. That's pretty good. So the good advantage what we have is you don't have to reboot the machine physically we don't have to do a reboot, the normal reboot. So all we have done is a virtual reboot, and you don't have to do anything with the kernel. Even if the kernel crashes, only the process crashes, which means, like, your original machine is up and running. So it is more like you're running a kernel in a virtual machine, like the virtualization thing. But UML is it's a simple thing compared to all the VMware, VirtualBox, whatnot, like Zen. Okay, I hope, like, this video gives you a good introduction to this UML thing. I mean, there is a lot more to explore. I mean, for example, you can load, you can also debug modules apart from the static code. If time permits, I will do that in my next session. Uh, so thanks for watching. Feel free to leave your constructive comments, suggestions, and anything you want to see in the future. Okay, thanks for watching my video. Have a nice day. Bye bye.